Yeah, so today we are going to solve the today's leetcode challenge. Question number 17, climbing stairs. Let's read the question statement here. So you are climbing a staircase, takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb to the top? So this clearly looks like a recursion question or tree question, whatever you call it. So let's let's imagine this is the staircase. Position 0, 1, 2, 3, 4, 5, and so on, right? So on and so on. So here, initially we are at position 0. Now, tell me, now we are at position 0, we have only two options, right? Either we can climb to the first, either we can climb one stairs and reach the this position, number one position, and either we can climb two stairs and jump to number two position. So we have two options. Option one, option two, OP2, OP1. Option one and option two. So at every stair, at every position, we have two options. Either we can go to the next position, or we can go the position after the next position. So let's imagine it like this. This is a tree, this is position 0, and we have two options. Either we can go to the next stair, we can reach the one position, or we can climb two stairs and we can reach the two position, right? And after this, again, we have two options. Either we can jump to the next stair and reach the second position, or we can reach the jump two stairs and reach the third position. Similarly, for this case, we can go to the third position, jumping one stairs up, or we can jump two stairs up and go to the fourth position. Similarly, here we can jump to the next position, third, or we can jump two stairs up and reach the fourth position. Similarly, here we can go to the next position, 4, sorry for this, or we can go to the two steps further and reach the fifth position, fifth. Similarly here as well. So here you will see one thing, that this branch and this branch is exactly same, 2 3 4, 2 3 4, and these two are going to return exactly same values, right? So doesn't make sense to calculate same branch, same thing multiple times. So it's better to use memoization here to make the time complexity, to reduce the time complexity, right? So yeah, if we'll not use memoization, then our time complexity can go to, like, for every position we are creating two branches, right? So that means for n branches we'll be creating 2 to the power n branches, right? Five. So our time complexity will be very high, like it can go to like 10 to the power 10. So I prefer, so jump to the let's jump to the question here. So I prefer Python. It's way more easier. Yeah. So first we'll be creating a memoization or we'll be creating a recursive function. So let's name the function stairs. And what are the arguments we'll be passing in the function? One is, first argument is going to be the index, the current index, or I should write current index, current index. And the next second one is going to be n, the limit n. So first let's try to make solve this question without using memoization, by just using recursion. So here, what should we return if we have reached the top of the stair? So if current if the current index is equals to n, that means we have reached the top. So we should return 1. What should we return if we have, you know, gone beyond the top? Like if we have reached the n minus 1 index and we have jumped 2 stairs from after that, so we should not count that result. So if n is have is less than current index, that means current index had surpassed n, then we should return 0, right? Now that these are the two end cases, right? Now what should we do at a particular index? So either we can climb one stair. So for the first one stair, we'll be, using this function, and we'll be passing values, the current index plus 1, or b equals to current sorry b equals to stairs current index plus 2, right? So these are the two cases or two branches. And what should we return the output? The output is going to be a plus b. Yeah, I think we're done here. And what should we write here? We should straight away write return retur and return stairs and we'll be passing 0 as our current index and n. Let's run this. Oh my god, here. Let me get rid of these things. So yeah, here you can see that our solution is running properly for these two test cases at least. Now let's try to submit it. I think we'll be having a time limit exceeded. Yeah, that's why it's taking so long. Yeah, so time limit exceeded. Now we'll be adding memoization here to reduce the time complexity. So what should we do to add memoization? Here we'll be passing an empty dictionary, and here we'll be storing the results in this dictionary, and we'll be naming it naming the dictionary memo. Memo stands for memory, and we have to pass it in these two functions as well. We passed it. Now we'll be using the memo. So if the ith index answer is already present in memo, then we'll be returning memo I. So here, if we have the ith index in memo, then we don't have to calculate it by this recursion function. We just have to return it using the memory, because we remember the solution, right? And here we'll be storing the answers here, storing the outputs. So memo for, not for I, for current index, memo for current index is equals to a plus b. Yeah, now let's run it again. Oh, okay. For I in memo, okay, it should be current index, right? Yeah, now it should run properly. Yeah, so it's running in these two test cases. Now let's try to submit it. Bullseye. So we have a successful submission here. Thank you for watching.